This video is about using SPSS to try to transform a skewed data set into a normal data set, okay? And I think I say it 1,000 times. Transformations, they don't work. They rarely work. One time in 1,000, if that, because I've done a million of them. But let's give it a shot. So here's our variable alcohol use. And let's look at the actual numbers. And you got some highs and you got some lows. But we're going to check the normality first. And descriptives, explore, get in there. And that's our only one. So let's do this. And we're going to check the Kolmogorov-Smirnov test and the Shapiro-Wilk, and we're going to look at the histogram. But again, histograms can be deceiving. So we're basically going to stick to one of these guys. So Kolmogorov, significant, right? That means it violated the assumption of normality, and the Shapiro-Wilk agrees. So let's look at there it is right there. So it's skewed to the right, obviously, right? So now let's try to transform this variable called alcohol use and see if we can't make the new transformed variable a normal. And again, it's not going to work. Okay. But what we would do is we would go to transform, compute a variable. And I'm going to call this first one alcohol. And I don't know, let's take the natural log. Good old E. And so that's what we do first. So you gotta pick the functions. I just click all and then go down to log. It's either ln or nl. There it is, natural log. You kick that up to the fix-it box, right? That's the numeric. So the question mark means what should I take the natural log of? And since we've only got one variable, we're going to kick it in there like that. So it's going to create a new variable that's the natural log of each and every measurement in the regular alcohol variable. We're going to click OK. And then we're going to look at the new variable, right? And so these are the natural logs. So in other words, E, that little magic number that's about 2.72, if you took 2.72, raised it by 2.4, you should get 11. 2.72 raised to 0.69 should give you around 2, etc., etc. So, but that's not what we're here for. We're going to go to Analyze. We're going to check to see if the new variable is normal. And I'd be willing to bet the farm that it ain't. But I don't have a farm. So, and then again, this is okay. We're just going to go by the Kolmogorov-Smirnov test again. And again, they are both still significant, which means it violated the assumption. And there's the natural log. I mean, it's just as bad as the first one. So let me try one more. Let's try, I don't know, let's take the square root or something. Transform, compute variable. This one I'm just going to call alcohol SQR2, RT, square root. And get that one out of there. Go to the function, click all, and square root, I think is down there somewhere. Square. There it is. Boom. Kick it up into the fix-it box. Square root of what? Square root of the original use variable. Click OK. Click that. And go back to our data set. Make sure it did show up here. All right, there's the square root. And again, these are the square roots of the original values. So we're going to check to see if this one's normal. Go to Analyze, Descriptives, Explore, out with the natural log, in with the square root, and click OK. And surprise, surprise, the Kolmogorov-Smirnov test and the Shapiro-Wilk test of normality both say that this thing is still not normal, right? So, and again, in my humble opinion, transformations are a huge waste of time trying to change a non-normal data set into a normal data set. One big thing that has always occurred to me is if it does change a non-normal data set into a normal data set, what it does is it changes the y-axis into a non-linear variable, right? The first one we used was a natural log. Natural logs, when you graph them, are curved, right? It's a curvilinear line, and with the square root, it kind of forms like a quadratic equation. So it's no longer a linear equation, a linear relationship, which we assume in statistics anyway. So MGZ.